Hello, dear friends. I hope everybody will be fine. Today I will start with the new chapter that is a shear force in bending moment. In this chapter, we will learn how to find out a shear force in bending moment and also the shear force in bending moment diagram. Now we will learn some basic points here. That is called types of load. Today we will learn how many types of load acting in a beam. Now we will learn. Let's start, dear friends. First, we have three types of load. First, point load or concentrated load. Point load or concentrated load. Point load is the load which is act at a point, or point load is the load which is act at a single point. Look at here. Point load acts at a single point is called point load. We have here a beam. Suppose this is A and B. We have a beam. In definition, we are learning the point load which is act at a single point. This is called a single point. This is the load W, denoted by kilonewton. The load is acting at a single point. This entire length is known as L. L is nothing but that is the entire span of the beam. This is a point load which is acting at a single point. In the second we have uniformly distributed load. Uniformly distributed load. UDL, uniformly distributed load. Uniformly distributed load is the load which is act the entire of the beam, or uniformly distributed load is the load which is spread at the entire span of the beam. Is called a uniformly distributed load. Suppose I have a beam A and B. The load which is spread at the entire span W kilonewton per meter. This length is known as span or length. The total load acting at a entire span of the beam. This load is known as uniformly distributed load. When we find the shear force in bending moment, and that point we should convert to the point load. Uniformly distributed load we should convert to the point load. This is called a uniformly distributed load. Sometime it's act like this one. I have this beam. Nothing will be there different, but only the difference is same. The difference is it will be easy to write down. W kilonewton per meter. This will be easily. Sometimes some people is writing this side or sometimes like this one, but only the difference is it will be easily to write this one. This is called the uniformly distributed load, which is spread at the entire span of the beam. In the last one we have uniformly varying load. Uniformly varying load. The load which is intensity is linearly varying between 2 points of the beam is called uniformly varying load. Maybe it will be trapezoidal shape, maybe it will be triangle shape. First point, like trapezoidal shape. How? Suppose I have this is a beam. W1 and W2. The load is acting in vertical direction like this. This will be trapezoidal shape. This length is known as L. L is nothing but that is the span of the beam. The total load load is equal to 1/2 into W1 plus W2 into L. This is nothing but that is the area of trapezoidal shapes. This is the total load is acting W1 plus W2 into L. And also total load is acting at a centroid here. W is equal to 1/2 W1 plus W2 into L. This is the total load. This W is a total load of this trapezoidal shapes. And second, an uniformly distributed varying load in second point. Maybe it will be like a triangle shape. Second pointer, maybe it will be like a triangle shape. Suppose I have this beam. Here it will be 0. The load intensity will be a downward direction like this one. This entire span is denoted by L. The entire span is denoted by L. Here the total load, load is equal to W is denoted by W. W is a total load, is equal to 1 by 2 into W into L. This is nothing but that area of the triangle. W into L by 2. This is the total load. And also the centroid of the beam is this one, centroid of the load here. That is the centroid. From this point to this point, 2 by 3 into L, 2L by 3. This point we should calculate like this one, the uniformly wiring load. Dear friends, this is a short video which I discuss the types of load. In next video I will explain the types of beam. Dear friends, please subscribe to my channel for more update videos with bell icon and share with your friends. Goodbye dear friends.